Hello everyone, this is a video for lab 10 where we will learn about spatial interpolation. So this is the method used to fill in the gaps in the data that are not continuous or scattered. So sometimes we have spatial data, but those are scattered in some points of the surface, but we might need the continuous data, like we might need a raster data for that particular area. So to do so, we use several processes like the IDW, Spline or Kriging. These are some kinds of spatial interpolation methods available in ArcGIS Pro. So we use this interpolation method to get continuous raster data from discrete vector points. We have this data for this lab that has been provided in Canvas already. You can check from there. So at the very first we will work with this ripple feature, and you can see that these are some discrete vector points, and we will run the IDW, the spline and the Kriging method of interpolation in this particular point data, and the result for our data will be a raster. As you can see now that we have run the interpolation on particularly the random field from the ripple feature. In the ripple feature, if you check the attribute tables, there will be so many fields, and we are particularly taking the random field to run the interpolation. Now you can see that there are several different rasters. The rasters from each of these interpolation methods are quite similar, but they do have some differences among them, as you can see. So this particular each particular interpolation methods actually has some unique processes underneath. So you can see that they particularly focus on different types of processes while running the process. So if you search in Google, you will be able, or there are links provided in this PDF file where you will learn that how IDW actually works, what things it considers while running, and also same for the spline and the Kriging. So these all are interpolation methods, but they have different kind of internal processes that they use to do the interpolation. Okay, now we have run the IDW with power 1, as you can see. So our first one, IDW with the ripple, was with the power 2, the default one, and now we have done the IDW again with a power of 2. So you can see that the IDW or output of power 2 is much more smoother than the IDW of a ripple with power 1. So this actually means that it takes more surface areas around it while interpolation when we take the power 1. So therefore it creates a more smoother surface. The instructions are pretty straightforward, so I'm just walking through the whole step-by-step process. You can just follow the processes yourself and provide the deliverables that are expected. So at the very first, you can see that your deliverable 1 is to export the image of Kriging and spline of the ripple feature. Then you have to provide the image of IDW with power 1 and IDW with power 2 images. That's the deliverable 2, I think. Now we will work with the ripple rand, and this time we will run all these spatial interpolation methods with using the value field as the Z value field. That the one we did with the random field, now we are gonna do that the same things with the value field. So a circular kind of raster you can see here. So we're going to run all of this interpolation methods one by one on this ripple rand feature, and we will keep everything else the same. So if you want to know more about these options, like the power particularly, we did the IDW on the ripple feature with power 1 and IDW on the ripple feature with power 2. So you can just click on the links that are available for IDW, and you can learn more about how changing the power while performing the IDW changes the output rasters, and what actually it follows while changing the power, and how it works internally. So you can keep in mind that you have to keep the names of this raster different from one another, otherwise you might get confused. So the outputs from the ripple rand can be named as the ripple rand Q5, Q4, and so on. So after doing all of these running interpolation methods in the ripple rand features, you have to run the all of these three in the ripple feature as well, but this time using the value field as the Z value field. We did that earlier for ripple features as well using that random field. Now we are doing that using that value field. Okay, it showed error as I mistakenly created another raster with this name earlier. So you can just change the name of it, and I hope it will work. Now simply the other settings will be just default, and you will run just using the value field for this ripple feature, using all these different interpolation methods. And I was talking about how you can change the power, and it brings change to the rasters. Like when you will use power 2, it will do the interpolation considering the values of the closer points. When you will use the power 1 while doing your IDW, it will consider the values of its surrounding points for a little bit. It will consider a little bit more points surrounding it. And when you are using the power 2, it will just consider some very, very close, but a few points closer to it. So the output result will be quite smoother for the IDW where you take the power 1. Now we will do some modifications and filter out some points using this particular definition query in the ripple rand at first. Like we will work with only those points that has the random value of equal to 5 or less than 5. So it might happen that we might not use all the features that are available in a particular shapefile. So we might need to work with some filtered values. So we are doing this to learn how the results of the interpolation changes when we take particular points from whole shapefile. And you can just use the SQL editor and get your SQL command. You can just copy those and paste it for both ripple and ripple ran. And we will do the same for the precipitation layer as well. All this data has been provided via Canvas. You can just download the data from there and work on that. So you can just turn on the SQL editor and copy and paste your command. Now we have some filtered points among all the values. Earlier we used all the points of the shapefiles for to do our interpolation methods, but now we will just take some of the filtered values according to our convenience actually. So you're gonna run the interpolation methods on these as well. Now make sure that you use the filtered records. It will be checked automatically actually, and you should get this kind of results from that. And you can see that this is very different from the one output of Kriging from ripple rand that we did earlier using all the points of the vector file of the ripple rand. But now when we are doing it using the some of the filtered values according to our convenience, you can see that the output result is definitely different from that. Now using Raster Calculator, we can calculate the difference in the rasters from the Kriging output of the filtered points from the Kriging output of the points of all the points when you considered all the points. So your result might look just like this. So this is the difference, the raster showing the difference between these two interpolation output rasters. We did it for the ripple feature. Now we have to do the same for the ripple rand feature. So we will take the one with the filtered now we have taken the ripple rand output raster from Kriging with all the points, the raster, the interpolated raster with all the points, and we have then subtracted the raster of Kriging from ripple rand with some filter points, and you will find this particular raster for the ripple rand as well. So you have to get those as deliverables. A 2-panel map displaying, one for the ripple feature and another for the ripple rand. So now we will use some more filters using our definition query. We will just select some particular area that are covered with some points. So we'll just get the points that reside inside this lat long. So we are filtering this further, like suppose you might have to get the values of particular weather stations that are located in the low-lying areas or any particular geographical location. So you can use these filters as well and run your interpolation. So it helps us to further modify our results and get more accurate results from interpolation. So you can see that our the points have reduced a lot because only these points lie within our preferred location. So this kind of look like such a cell division. So according to our choice, we can use different definition queries, and according to our commands, the particular data will show up and we can run our interpolation on those particular data. You can follow the names that I've used, so it will help you out to easily prepare your deliverables. Okay, we'll find out this kind of rasters. Now you can get rid of it. You have to delete the definition query because you're gonna do a spline. You're gonna use this spline interpolation method in the precipitation layer, and your spline will just look like this. And as I said earlier, each of these interpolation methods use unique or considers unique processes while performing their interpolation. So according to your kind of data, your type of data, your location, and your expected outcomes, you have to use different kinds of interpolation methods like the IDW, like the Spline, and sometimes the Kriging. So we are using some different kind of commands for this precipitation layer, and the instructions are given in the PDF file. So these are sample commands, and you have to use your simply like you were doing a project, and you might have to get the values for different points of weather stations. So in that case you have to use different kind of commands for your convenience. So after running this particular command, you can see that we are left with just some points in these four corners, and we will run our spline again. And at the very last, we will just calculate the difference between the spline with all the points and the spline with just a few points in these four corners. And this will be our last deliverable, I think. So if you just see the descriptions of IDW, spline, and interpolation, and Kriging, you will simply find out that which interpolation methods suits best for your kind of data that you are working on, because each of these interpolation methods focuses on different parameters while running their interpolation, but each of this actually do the interpolation. I mean, it makes the district data and converts those into continuous rasters. So make sure to check all these deliverables and provide the deliverables to me. And you will also have to answer a few questions here. Thank you. I hope it helped.